A cost-effective approach to storage at PPG's Springdale Coatings facility. PPG Industries is a Fortune 500 supplier of paints, coatings, optical products, specialty materials, and fiberglass, with their global headquarters located in Pittsburgh. The focus of our project is PPG's industrial coatings facility located in Springdale, Pennsylvania. The facility produces custom paints and industrial coatings in a 204,000 square foot, 3-story facility which includes production floors, office areas, and a warehouse. They produce approximately 1 million gallons of paint per month. The facility runs 3 8-hour shifts a day, Monday through Friday. However, currently overtime for the operators have extended production into the weekend. Our project concentrates on the present issues with the storage area adjacent to the production floor. With the current arrangement of storage, PPG is only able to store about 70% of the raw materials used on the floor near the production area. This capacity issue has led to long material retrieval times and production delays, causing the plant to run overtime to meet product demand. The current layout of the storage area adjacent to the production floor contains 12 rows of raw materials arranged on shelves of pallets. Each raw material is organized by the production cell in which will be used. We identified several areas of opportunity in the storage area. First, because there's overlap between many of the materials used in the different production cells, items are stored in multiple locations on the second floor. Second, the inventory management system used to inform the operators of the locations of their materials is often inaccurate, causing them to spend additional time searching for materials. Third, the inaccuracies in current method of retrieving materials one at a time results in long material retrieval times for the operators.
We began by talking to the operators on the production floor to gather some qualitative data. We then performed time studies in multiple production areas to collect data on how an operator divides his time between tasks such as making paint and retrieving raw material. PPG provided more information to us on the factory's raw material consumption in the past year. The final step in the data collection process was obtaining data at the beginning of each week on the type and quantity of material stored on the second floor shelves. After a discussion with our primary contact at PPG, we decided to make the following 2 assumptions in our analysis. The first was that any time saved during the normal Monday to Friday work week could be directly translated to overtime savings of the same amount. The second, to simplify our calculations, was to assume that each drum of a raw material weighs 400 pounds. Finally, we had to recognize and work around some problem constraints. PPG handles many flammable raw materials, and we had to be sure to adhere to proper engineering standards when storing these materials. There were also structural constraints that we needed to work around, such as support beams that left some pallet spaces unusable. Once armed with the proper data and knowledge of our assumptions and constraints, we developed a plan to assess the problem. We first wanted to know how much time the operator spent on material handling and if that could be reduced. Next, we looked to determine the current cost of production delays. Our team challenged the notion that every product on the second floor shelves was essential to current production, and our final task was to develop a cost-benefit analysis of a new material handling system, specifically adding the position for an employee to kit raw materials for operators instead of operators pulling the materials themselves. Our first action item was to create an inventory management system that PPG could use repeatedly to assess their current inventory. We developed an Excel workbook with a macro to allow PPG personnel to search for outdated materials. The user can simply input the latest raw material consumption data and inventory count, and then search for old materials with the click of a button. Products can be identified by the number of days since last usage or number of days since they were moved from their current location. This tool should allow PPG to locate and dispose of materials that are taking up valuable pallet spaces in storage.
A quick look at the data showed that PPG can free up to 130 pallet spaces by getting rid of materials that have been in storage for over a year. Our team then looked into additional space-saving solutions. Currently, PPG separates raw materials on the racks by which area or cell they are intended for. While convenient, this means that if the same material is used in more than one cell, it can be stored in pallet spaces in multiple shelves. An analysis showed that if PPG changes their system and consolidates each material to one location, they can reduce inventory and free up to 329 pallet spaces. It is worth noting that another 154 can be opened up if PPG makes products on pallets, but after speaking to PPG, it was determined that this is not a feasible solution within the current system constraints.
The final step to this project was to analyze if adding designated employees to kit materials for the operators would be cost efficient for the company. From our time studies, we were able to determine that about 9% of operator time was spent retrieving and putting away raw materials on the second floor racks. If this time was spent instead on production, approximately 4 hours of plant overtime could be saved per week. By reducing plant overtime, time, the overtime wages of 85 employees could be reduced, as well as the overhead cost of running a factory for 4 hours. Even after the additional cost of kitting, this is projected to save the PPG Springdale plant about $140,000 a year. The figure on the right shows the sensitivity analysis for this annual savings figure. Not storing by cell has two major benefits on the factory floor. First, it reduces the space needed for storage because fewer pallets and materials will need to be stored. It also reduces the time spent searching for materials. Presently, some materials are stored in multiple locations, so a worker may have to go to multiple places to find his product. Not storing by cell eliminates this effect, thus reducing material handling time. Implementing a kitting system also reduces material handling time. The majority of the kitter's time will be material retrieval, so they will quickly become familiar with material locations. These kitters will then be faster than the operators who are not as comfortable getting material. Lastly, the kitter's experience in retrieval will reduce the chances of any accidents, which could improve worker safety. In order to implement this project, PPG will need to first eliminate storing by cell so each material is stored in one location. Next, they need to use the inventory management model to identify and remove unused old materials. These two steps will open up a significant amount of storage that will allow space to be used for kitting. To implement a kitting system, they need to relocate the materials in the kitting area as well as remove the 2 rows of shelves. They will then need to hire kitters and properly train them. Finally, they will need to educate their operators on the new material handling system. In the long term, they should reevaluate their kitting system to identify any opportunities for improvement. They should also routinely use the inventory management model to ensure that old, unused materials are not stored for a long duration. We would like to thank the following people who helped to make this project a success.